In this video tutorial, I'm going to cover some examples of the Poisson distribution. Let's start with this example. At a service desk, the customers arrive on average 10 per hour during the morning shift that goes from 8 to 12. The service desk manager wants to determine the staffing level for this shift. He wants to know what's the probability that there will be 15 or more people that will arrive between 8 and 9. Now, the Poisson distribution is often used when we want to model the frequency with which a specified event occurs during a particular period of time. In our example, the event is the number of customers that arrive at the service desk, and the period of time is per hour. So the Poisson distribution is all about something happening during a time interval, or area. However, in order to use this type of probability distribution, we need to consider some assumptions. The first assumption is related to the interval of the observation that must be fixed in advance. And in our example, the interval of the observation is per hour. The second assumption is related to the average rate of the events that must be constant. In our example, we have 10 people on average that arrive at the service desk each hour. The third assumption is related to the independence of the occurrences. And in our example, we can assume that one customer that arrives at the service desk does not influence the arrival of another customer. Now that we know that our example is meeting the three assumptions, let's see how to do it in Minitab. So we click on Graph, Probability Distribution Plot, View Probability. Then we select the distribution, which is the Poisson distribution. Then we said that in our example we have 10 people on average that arrive at the service desk per hour. So the mean is 10. And then we want to know what's the probability that 15 or more people will arrive at the service desk between 8 and 9. So we go into shaded area and we choose X value, and then we choose the right tail because it's a cumulative one, so 15 or more people. So the X value will be 15. When we click OK, we can see that Minitab is showing that the probability that 15 or more people will arrive at the service desk between 8 and 9 is 0.08 or 8%. Let's see another example. Here is the question. The average number of car accidents per month on a certain road is 3. What's the probability that in any given month 4 accidents will occur? So we click on Graph, Probability Distribution Plot, View Probability, the Poisson distribution. The average will be 3 because the average number of car accidents per month on a certain road is 3. Then we go into shaded area, and considering that we want to know the probability that in any given month 4 accidents will occur, then we choose X value, and it's a specific value, so we choose middle. We do not have a range because it's a specific value, so we just enter 4 and 4 in the two boxes. When we click OK, we can see that the probability is 16%. Let's see another example. The average number of emails that arrive in your mailbox is 12 per hour. What's the maximum number of emails that should arrive in any 1 hour with at least 90% certainty? We click on Graph, Probability Distribution Plot, View Probability. Okay. Then we select Poisson. Then the average is 12 because we have an average number of emails that is 12 per hour. And in shaded area this time, we select probability because we want to know what's the maximum number of emails that should arrive in any 1 hour with at least 90% certainty. So we do not have a specific value this time. We have a probability of 90%. So we are looking at the left tail, and by default Minitab suggests 0.05. We change it with 0.9 because it's 90% of probability that we want to know. So when we click OK, we can see that the maximum number of emails that should arrive in any 1 hour it's 16 with 90% certainty. Hope this has been useful. Thank you for watching.